Hello, Latin geometry students. For this assignment, we're going to continue talking about parallel lines, transversals, and angle pairs. Now, we're going to mix together things we've done in the last two lessons. In this case, we're going to take this picture that we have drawn a couple of times, and we've described the names of the angle pairs, and we're going to make a small change to it. We're going to take one of the lines and turn it until our two lines are parallel to each other, and now we have parallel lines crossed by a transversal. These two lines are now parallel. Now we've already seen that when they're parallel, we see a pattern in the angles. And the pattern looks something like this. If you have these two lines parallel, then if I try to make this angle bigger or smaller, the exact same thing happens to the same angle in the other location, at the other intersection. In other words, when my lines are parallel, my corresponding angles have to stay the same. They are congruent. That only happens when the lines are parallel. So if we start with a picture like this where we know our lines are parallel, if we know the measure of one of the 8 angles in our picture, let's say this one, this 120 degrees, we can actually figure out the measures of all 8 of the angles. You work your way around the picture to find the measures of them, but then a pattern emerges and you can skip around the picture. For example, we would start here, maybe starting with angle C. If this angle is 120, well, the 120 and the C, those are vertical angles, so C has to be 120 as well. Then, again, working our way around this intersection of angles, these two angles make a straight line, so they have to add to 180. So if this one's 120, then the one next to it has to be 60 as well. Then again, by vertical angles, if this angle is 60 right here, then angle A is going to have to measure 60 degrees as well. Now, that's old, but what's new here is when the lines are parallel, we see the exact same numbers in the exact same locations at the other intersection. The corresponding angles are congruent, or they have the same measure. So if the upper right angle here is 120, then the upper right angle down here is 120. So I know that this angle is going to match that one. And then as we try to figure out the other angles down here, we're going to get the same measurements in the same locations. If this angle is 120, then this one's 60. This one's going to be 120, and this one is going to be 60. So when we have parallel lines crossed by a transversal, we always get this pattern to our angles, where all the angles in the picture have only two measures, and things are either equal to each other or they add to 180. Again, that's a common theme in geometry. Things are either equal or they add to 180. So whenever we have this picture, if I give you the measure of one angle, you can find the measures of all the other angles. Take a moment and answer the questions and see if you can find the measures of the other angles. Okay, if this angle is 105, then the one next to it, making a straight line, they add to 180. So this angle has to be 75. Where did you get that? Just did 180 minus 105, and that tells me this angle. And if I know this angle, I can find the one next to it, angle G here. And then if I know this one, I can find this one. Or we can find them directly by using vertical angles. Either way, angle G is 105, and angle H is going to be 75. Since the lines are parallel, we can tell from these arrows down here, we're going to have the same measures over here for A, B, C, and D as their corresponding measurements over here. So in this picture, angle B is going to be 105, angle D is 75, angle C is 105, and angle A is 75. There's a shortcut to doing this rather than go through and find all the angle measures, because sometimes we're going to be asked to jump around the picture. You might notice a really simple pattern. All the acute angles have one measure. All these angles that are smaller than 90, the little angles, are all 75 in the picture. And all the obtuse angles have the other measure. They're all 105. So when we have a problem, instead of finding the measure of every angle, we can jump from one angle to the next. So we always see this pattern. When our lines are parallel, all the small or acute angles have one measure. In this case, all the red angles are the same. And all the obtuse angles have another measure. In other words, all the green angles are the same as each other. And if you mix a red angle and a green angle, if you have a little one and a big one, they have to add up to 180 degrees. So if we put all that together, here's an example of a problem. where we're told these two lines are parallel, so we're going to see that pattern to our angles here, and we're given the measure of one of these angles. This angle is 45. We have to find x and y and z. Instead of writing in the measures of all the angles all the way around, and you certainly can do that, but you don't have to. See, whenever you see a problem like this, the first thing you can do is I know this angle is 45, so I know every angle in this picture is either 45 or whatever 180 minus 45 is. So when you see a problem like this, you can just pick up your calculator and start with 180 minus 45. If you do that, you get 135. So every angle in this picture is either 45 or 135. You can jump to the answers by just looking at the angle and deciding if it's acute or obtuse. For example, this angle x here. This is an obtuse angle. It's clearly obtuse in this picture. That means it has to be more than 90. So it doesn't make sense for this angle to be 45. So this angle instead would have to be 135. We jump over here to y and z. If we look at angle y, this is clearly an acute angle. So its measure is going to have to be 45. Angle z is an obtuse one. So its angle can't be 45. It has to be more than 90. So angle z is going to turn out to be 135. If we add more parallel lines, we just get the same pattern repeating and repeating. So again, in this picture, if we know the measure of one angle, if we figure out that this one angle is 110, then immediately pick up your calculator. 180 minus 110 is 70. Every angle in this picture is either 110 or 70 because they're all separate. They're all created by parallel lines. So you could go through this first set of intersections, figuring out these angles. If this one's 110, then you can find those four angles. And then because these two lines are parallel to each other, down here we'll get all the same measures in all the same or corresponding locations. We'll get 110 and 70 for all four of these. Notice again, all the obtuse angles have 110 degrees for their measure. All the acute angles have 70 degrees for their measure. And then because the left line and the right line are parallel, we'll get the exact same measures over here at this intersection, where all the angles are going to be 70 and 110. And then again, because the top and bottom lines are parallel, we'll get the same measures for these angles. All these angles will be 70 and 110. All the acute ones are 70, all the obtuse ones are 110. So whenever we have this picture where we have two parallel lines that are crossed by a transversal, we have 5 rules that show up. First off, the alternate interior angles are congruent. This little angle right up here is the same as this little angle down here. They're alternate interior. They'll always turn out to be the same. And same with the obtuse ones on the upper right over here and down here. The alternate exterior angles will turn out to be congruent as well. The corresponding angles will always turn out to be congruent. The same side exterior angles, if we look at a set of same side exterior, here in the upper right at the top intersection, this is an acute angle. And in the bottom intersection, the bottom right, it's same side exterior, this is an obtuse one. Those two angles, an acute and obtuse, will always add to 180, which we have a word for. Those are called supplements. So same side exterior angles are always supplements when our lines are parallel. And likewise, same side interior angles are always supplements when our lines are parallel. That's this angle here and this one right here. One obtuse and one acute. Those are going to add to 180 or be supplements. Those same rules work backwards as well. In other words, we know these are true because the lines are parallel. But if any of these things are true, that tells us the lines are parallel as well. So in other words, if alternate interior angles are congruent, then the lines have to be parallel. Or if corresponding angles are congruent, then the lines had to be parallel. Or if alternate exterior angles are congruent, the lines are parallel. Or if same side exterior angles are supplements, then the lines are parallel. Or if same side interior angles are supplementary, then the lines are parallel. That's a lot to remember. That's 10 rules about alternate interior and same side exterior and lines being parallel. It can be easier to remember it like this. Whenever the lines are parallel, we see this pattern. See, these two lines are parallel, so all these red angles are congruent, and all these green angles are congruent. And a red angle plus a green angle, or an acute plus an obtuse, add to 180. It works backwards. If we see the parallel lines, then we get this pattern. But if we see this pattern, then we know the lines are parallel. So this works both ways. If you can find matching angles at the different intersections or supplementary angles in the right locations, then we automatically know that the lines are parallel to each other. Okay, so if we mix that back with what we learned about angles and things either being equal or adding to 180, we can run into problems like this where we're asked to solve for x. When we have a problem like this, we're looking for parallel lines. This line and this line are parallel to each other, so we know we get this recurring angle pattern here, which means in this picture, every angle is either equal to each other, or the same measure, or they're congruent, or they're going to add to 180. So if we're asked to solve for x in a problem like this, and this is what we're going to do a couple of these in a row, the first question is trying to decide if these two angles are equal or do they add to 180. And again, the easiest way to decide, if we look at them, are they both acute? If they're both acute, they'll be congruent or they'll be equal. If they're both obtuse, they'll be equal. But if we have one of each, they'll add to 180. Look at this picture. This is an acute angle. This is an obtuse angle, which means these two angles are going to add to 180. If they add to 180, then we're going to solve for x by creating an equation. The first thing to do, since they add to 180, we're going to add them and make that equal to 180. 6x minus 2 plus 10x minus 10 is equal to 180. Then we go through the steps, the algebra to solve for x. In this case, x will turn out to be 12. I skipped a couple steps in the middle there. The third question we could be asked is, what are the measures of the angles in the diagram? In other words, we have to take the 12 and plug it back in for x. 6 times 12 minus 2 would be 70. 10 times 12 is 120, minus 10 would be 110. You can check really quickly if you have those correct because those are supposed to add to 180. 70 plus 110, oops, 70 plus 110 would be 80. And these are the questions you ask yourself for each problem. For example, in this problem, we want to look at the angle measures and decide if what's supposed to be equal, what's supposed to add to 180. But again, the fast way to do this is either one of two ways. Either start filling in all the angle measures and then go back and answer the questions. Oh, x is 60, y is 60. A couple extra steps there, but it's pretty simple to follow. Or just identify whether things are are acute or obtuse. See, this obtuse angle here is 120, so all the obtuse angles are 120. And then we do 180 minus 120, and we get 60. All the acute angles will be 60. If we look at x, x is acute, so it'll be 60. If we look at y, y is acute, so it will be 60. All right, so let's try this here. One of the angles is 100. Can you figure out what x is and then what y is? Start off by deciding what the two angle measures in the picture are. Every angle in this picture is going to measure 100 or what? Well, it's 80. So every angle in this picture is either 100 or it's 80. 100 is more than 90, so all the obtuse angles would be 100. 80 is less than 90, so all the acute angles would be 80. Look at x, decide if it's acute or obtuse. Look at y, decide if it's acute or obtuse, and figure out their angle measures. If you want, you can fill in every angle measure. If you don't like doing it that way, that's fine. But x is an obtuse angle, it will be 100. Y is one of the acute angles, it will be 80. Here's another one. See if you can figure out the measures of x and y. And in this case, if you fill out all the angle measures, all the acute ones here are 70. Both x and y turn out to be obtuse. So if you do 180 minus 70, we get 110 for both of those. Okay, here's a slightly harder problem. In this case, we look at these two angles, and we have an x, and it's not just an x, but we want to figure out, we're going to have to solve for x in this case. This angle here is 120, that's an obtuse angle. This angle down here, the 3x, is an acute one. They're not congruent. The 120 has to be more than 90, the 3x has to be less than 90. They can't be the same. That means instead, they have to add to 180. So we can literally write the equation, 120 plus 3x is equal to 180, and then solve this equation. Very simple. Subtract 120 from both sides, we get 3x equals 60. Divide by 3, and we get x is equal to 20. You might be thinking, didn't you just tell us we could just fill in all the angle measures like this? Couldn't we just know that 3x is equal to 60 and skip to the second step? Yes, absolutely. In fact, that's a great way to do this problem If that's what makes sense to you, that's how you should go about this problem. This one, same idea. We look at our two angles, we're going to try to solve for x, but first we have to ask ourselves, are they supposed to be equal or add to 180? In this case, both of the angles are obtuse, so they're going to be equal to each other. So then we write an equation. If they're equal, then we write this one equals that one. And we get 135 is equal to 3x plus 15. Then we just have to solve for x. Subtract 15 from both sides, we get 120 equals 3x. Divide by 3 and we get x is equal to 40. Here's another one. First question, equal or 180? These are going to have to add to 180 because one of the angles is an acute angle and one of them is an obtuse angle. The 75 is acute, the 4x minus 9 is obtuse. They can't be equal, so instead they're going to add to 180. So we write that equation. This one plus that one equals 180. Once we have that equation, 75 plus 4x minus 9 is equal to 180, then just apply some algebra to solve for it. Combine our like terms. 75 minus 9 is 66, so we have 66 plus 4x is 180. Subtract 66 from both sides, we'll have 4x is equal to 114. And divide by 4, we'll get x is 28.5. Okay, slightly harder problem because we have a few more x's in this problem. There's no arrows here telling us the lines are parallel, so it says it right here. A is parallel to B. So it's still the same idea, though. These two angles. Step 1, are they equal or do they add to 180? They can't be equal because one is acute and one is obtuse, so they're going to add to 180. So then we write an equation for that. 11x plus 3 plus 15x minus 5 is equal to 180. Then we just have to solve this equation. Combine our like terms. We're going to have 26x minus 2 is equal to 180. Then simply add 2 to both sides and divide by 26. We'll get x is equal to 7. You may be asked to find the angle measures. No problem. Plug 7 back in for x. 11 times 7 is 77 plus 3 is 80. 15 times 7 is 105, minus 5 is 100. And then you can check because 80 plus 100 equals 180. Here's another problem just like that. Step 1 is to decide, are these angles supposed to be equal or add to 180? These angles are going to have an equal measure. They are congruent because they're both acute. These are alternate interior angles. So we'll say that these are equal to each other. So our equation, 20x minus 12 is equal to 17x plus 3. And then we simply solve for x. Subtract 17x from both sides. We have 3x minus 12 is equal to 3. Add 12 to both sides. We get 3x is 15. Divide by 3, x will be 5. If you were asked to find the angle measures, take 5 and plug it back in for x. 20 times 5 minus 12, and 17 times 5 minus 3.